All right, welcome to WASA Distance Education. This is MBF3C, grade 11 college prep math. I'm Pete and I'm your teacher. And this is the end of week 3, the last lesson in week 3. This one went kind of fast because we only had 3 classes this week. Okay, and yeah, so if you missed the lesson, you can always check out the archives, the WASA archives, and you can always also check out my YouTube channel, PW Space WASA. Now, I think we might be a little behind in putting those YouTube videos up just because I've been actually at a symposium this week, so it's kind of a cool thing. So that might take until tomorrow to get those posted. So yesterday we looked at the compound interest formula and we saw that it's different than the simple interest formula. The idea is really the same, is that we have a compounding period and an interest rate. We calculate the interest that's earned over the compounding period over the term of the investment or a loan. And then the difference with simple interest is that we just kind of hand you back the interest. Whereas with compound interest, we actually take that interest, we put it back, mix it in with the principal, we compound it with the principal, and then we, in the next compounding period, calculate the interest, the new interest based on that compounded amount of money, the principal and the interest from last compounding period. Okay, so investments grow much quicker with compound interest, which is good if you're an investor. And things like mortgages and loans and credit cards, the interest due on them grows very quickly if you're borrowing money. So and banks and financial institutions, it's always going to be compound interest. Okay, there's really no such thing as simple interest. You might simple interest if so you lend someone $50 and you pay them back, or they pay you back after a week. Maybe you'll charge them $1. That's simple interest. But anything other than that, it's going to be compound. If you're dealing with a bank, it'll be compound interest. So we looked at compound interest yesterday, and we also looked at the idea that the compound interest formula is an exponential function. Okay, a linear function, which what we looked at is simple interest, but compound interest is an exponential function because it has a variable in the exponent. It's to the power of n, basically, is the formula. Okay? That's what makes it an exponential function. So we're going to take another look at the compound interest formula, just a bit more detail, and study the compound interest formula because it's used quite a bit. It comes up all over the place in business, and it's also just useful to be able to work things out on your own. Okay. So we're in Unit 2, okay, and it's page 16 of Unit 2. Okay. So we're going to learn how to find various values, because there's 3 variables that we use in the compound interest formula. There's the P, right? There's the I, and there's the N. And well, there is the A, the amount, right? So if we have 3 of those 4, then we can find the other one. Okay. Now some of them are pretty straightforward. We're going to look at finding the principal. That one's just a matter of manipulating the formula. So let's take a look at this. This is page 16 here of Unit 2. Okay. Let's have a look here. See who we have. So, of course, P, the principal, is the money that's invested today, so you have a certain amount in the future. So sometimes the problem is not, I have this amount of money to invest, how much am I going to make at the end of it, but rather something that if you're retiring, if you're thinking about retiring, or if you're thinking of going on a vacation, or maybe you just want to buy an iPad or something next year. So you can say to yourself, okay, I need this amount of money, right? Maybe I need, $1 million to retire, right? In the style that I want. Maybe I'm going to take a vacation, so I need $1,000 to go to Cuba next year, right? Or, I'm going to buy an iPad mini, for my little sister, my little brother. and so I'm going to need $500 for next Christmas. How much money do I have to invest now in order to meet those goals, right? And so that's the principle that you're going to need to invest. So the way you do that is you know your A. Your amount is the amount of money you're going to need at the end of the investment. And then you just manipulate the compound interest formula until using your knowledge of algebra until you get P by itself. And that's the principle you'll need to invest. Okay. So that's how we use it, and that, it's a good thing to be able to do. So let's take a look at example one. Okay, it says Mrs. Kim has some money to invest. Okay, she would like to give her grandson, Carl, this is great, $10,000 on his 16th birthday. Now that is a really nice cookie. Really, really nice. So she wants to give her grandson, Carl, $10,000 on his 16th birthday. Maybe he'll buy a car, maybe he'll buy a snowmobile, something like that, right? Maybe he'll put it in his college fund. But that's a great present. So Carl is celebrating his 10th birthday today. Okay, so now we know, right? She's got a few years now, right, to make that $10,000 happen. How much must Mrs. Kim invest today? So that's our right at 6% compounding monthly. Okay. So today means that's the principal. That's what she's talking about. We want to know the principal, and she wants to give the $10,000. That's the amount. You see? So that's, now I think we have pretty much everything we need to solve this. Okay. So what I'm going to do, just got to find a page in the book here. Sorry about that. So what I'm going to do is make a new page and solve it. Now I know it's given there. The solution is given there. I may or may not do it differently from the way the book does it. The reason I want to show you how I do it is just so sometimes you'll get a couple of different ways to do it. So this is example one. Okay. And so our A, we've decided that our A is $10,000. Okay, now in the book they use a space. That's a modern way of formatting numbers. Those of us who went to school back a few years ago use a comma to group groups of 3 digits in our big numbers. Either way is perfectly fine by me anyway. So we don't know the P. That's what we want to find out. Our I. Now what is our I? They gave us the interest rate was 6%, and it's compounded monthly. Okay, so remember that our I is our interest rate divided by 100, so expressed as a decimal, 0.06, divided by the number of compounding periods per year. Monthly, there's 12 months in a year, so that's going to be our I. Okay. Now, I didn't write that really well. I'm just going to rewrite that. I don't know. There you go. Okay. So it's a little easier to read. And that's the thing about writing math. If you scratch something out or whatever, it's fine as long as somebody looking at it afterwards can read it. It doesn't matter, right? In my case, I could have scratched out and wrote it in bigger. I just had a chance to erase it straight away. Okay, so N. Now here's the thing, our N, that is the total number of compounding periods. So we know that there are 12 compounding periods per year. So it's going to be 12 times however many years the investment runs, right? So if we look back at the question, and this is the first step of the 3-step problem solving model. And really, we're kind of doing 2 steps at once. We're doing step 1, which is understanding the question, and step 2, which is devising a plan, right? And what we're doing is we're loading up our formula, right? We're getting all the numbers sorted out. We know what formula, we picked it out. We think we got the right formula, right? Now, when you get out there and you're solving different types of problems, and especially in like chapter 3 of this, or unit 3 of this course, what you're going to find is that the formula you use is not always obvious, right? There might be 2 or 3 different formulas you could use. And so the part of devising a plan is to pick your formula and try different sets of see what you get, see what you can figure out from the formula you pick, right? So that's the thing about this course, is that you're going to kind of have some experience in dealing with situations where it's not always clear what formula you're going to use. So what do we got? So it's n is 12 times. Now let's go back and understand the question. Carl is celebrating his 10th birthday today, and how much must he invest today? So well, if he's 10 now, and it's got to be on his 16th birthday, so then 16 minus 10 is 6. So it looks like it's going to be for 6 years, right? So let's see, what do we got? 60, is that 72? Looks like it might be 72. Okay. Compounding periods. Okay, double check all that. I think we got it right here. That looks good. Okay, so now we've done step 1 of the problem solving model, which is to understand the problem. The problem is that we need the P. That's what we need to figure out. We don't know that one. Okay, but we have all the other variables that we need. So let's write out the formula. A equals P times 1 plus I to the power n. Okay, so now we're set. We've done step 1 of the 4-step problem solving model. We figured out what the question is. We need to find the P. We devised a plan, which is to use the compound interest formula, and we have all the numbers we need. And now we're going to implement the plan. That's step 3. And step 3 just says, okay, we need the P. Now let's use our knowledge of algebra to figure out how we're going to solve this, right? And the way we're going to do it is we're going to take the stuff that's on the left-hand side, sorry, the right-hand side. Don't say left. It's funny because that's what I was thinking in my mind. Don't say left, and I said left. It shows you gotta think about where you want to go, not where you don't want to go. That's a piece of advice that I read in a book about mountain biking. How not to fall off a cliff on your mountain bike. Don't look down. Look on the path. So in my case, I should have said we got to divide the stuff. We got to take away the stuff on the right that is not P. So we have 1 plus I to the power n, and that is an expression that can be moved right over onto the left-hand side. We just divide both sides by that, right? 1 plus I to the power n equals P, right? Perfectly valid thing to do. And the reason is that if you worked out what 1 plus I to the power n is, it's a number, right? And it can't be 0, because otherwise we wouldn't be doing the problem, right? So it's got to be a number that we can divide both sides by. Okay, just because it's a funny looking expression, it's still a number, right? And we can divide both sides by it. So that's what we did. We divided both sides. Now I didn't show the division on the right-hand side, and then the canceling out, because that's all we'd be doing. We'd be putting, we'd write P times 1 plus I to the power n over 1 plus I to the power n, and then cross both of them out, and we'd be left with P. So I skipped a step, basically. Okay, you can write that step if you want. Well, now we have P by itself, and everything on the left-hand side, the A, the I, and the N, we know what they are. So let's just now implement our plan. We're going to plug everything in. Okay, I need the A. And let's just plug everything in. Look at this. 10,000 on the A, dollars, and then 1 plus I. Now our I is 0.06 over 12, right, to the power n, which is 72. Okay. Now, notice I left it sitting as a fraction. Okay. It's a wise thing to do. That way, if you find you made a mistake on, say, the I, let's say somebody comes along and says, oh, no, it was 6.5%. Sorry about that. Then you can just go and change it. It wouldn't take you, it would take you, not even 10 seconds to change it everywhere, and then just recalculate the last step, right? So that's why we leave it as a fraction like that, right? Or if somebody says to you, well, what would it be if it was a weekly compounding instead of monthly? You just change the 12. You'd have to change the 12. You'd have to change the n, right? And you could do that fairly quickly. Okay, I'm just going to extend the page so it'll scroll up on you. And so now we just got to crank this whole thing into the calculator. So the way I'm going to do it is the way I talked about doing it yesterday. Just you know, you can do it in any order you want, but I just find it easier to start down here. I do the fraction first, so it's a 0.06 divided by 12 plus 1. Okay, actually, I'm just gonna, whoops. All right, let's try it one more. Whoa. All right, I'm not sure what I think I went back one too many times. I didn't know you could do that. Oh, boy. Okay. I got my problems writing on this. Really, it's a really cool thing. It's a sort of like a whiteboard, but it's made of glass. It's a big iPad. Okay, so let's try this again. So I'm going to say 10,000. I'm just going to do maybe one step that I wouldn't normally do. What I did was I evaluated the stuff inside the bracket on the 72. I want to write 72. I don't know what I started writing there, but it's supposed to be 72. There you go. Okay, so I just took one extra step. Now the next thing I'm going to do is I'm going to evaluate 1.005 to the power 72. And the 1.005 is already in my calculator. See, what I want to avoid is having to type stuff back into my calculator. Like this number that I'm about to write out, I don't want to have to enter that back into my calculator. What are the chances that I'm going to get that back in there in exactly those digits? I might make a mistake, right? In the case of the one just above, 1.005, what if I added an extra zero? What if I left one off? So the fewer times that you have to enter stuff into your calculator, the better you are. Okay. So now what I have here is I have this number in the denominator, and I'm supposed to divide it into 10,000. What I'm actually going to do is divide this 1.43 by 10,000. And then I'm going to take the reciprocal, which on some calculators it's like that, and then on other calculators it looks like that. I'm just going to press that button. Okay. And then we got a number, which is a dollar amount, 698302. I just rounded it off to 2 decimal places because that's our answer, right? We don't need it again. If we needed it for some other calculation, I'd probably keep a couple extra digits just to be as accurate as possible. That's a 2. It's a rather ugly looking 2. Okay, it's only a little better. So what does this mean? What does 6983.02 mean? What if we didn't even know it was dollars? Okay, well, let's take a look at the original question. The original question was, how much must Mrs. Kim invest today at 6% compounding monthly? Remember, she wants to give her grandson $10,000 when he turns 16 in 6 years. She has some money. How much does she have to put in a bank in a guaranteed investment or term deposit or one of those investment things, right? And that's how much it is. It's just a little under $7,000, $6,983.02. Right? Well, that's a pretty good deal for both of them, right? She has some money. She's going to put it away, not think about it for 6 years, right? And when he turns 16, he gets his check for $10,000, or maybe he gets a bank account with $10,000 in it. And then he can do, depends on, maybe he wants to buy a car, maybe he wants to put it in his college fund, but that's a great thing. But that's planning ahead. Now she doesn't have to touch it. She doesn't have to add any money to it. Okay, this is just a lump sum that she puts in an account, and 6 years later it's worth $10,000 at 6%. Now 6% is a pretty high interest rate these days, but it's still you can do similar things. Just you probably wouldn't get quite as much. So let's answer the question then, Mrs. Kim. Okay, Kim, this is worth about 1 mark if you're keeping score, right? So if you got a 3-mark question or a 4-mark question, you'd lose a mark if you didn't put a statement at the end of it. If it's a if it's a word problem. Mrs. Kim must invest and I mean you don't have to write a novel here. Just just answer the question. One of the ways to do it is to turn the question around. It says, and that's what I do, how much must Miss Kim invest today at 6% compounded monthly? Miss Kim must invest this amount of money today to get, okay, and I got to extend the page, to, in 6 years, whatever. You know, when our grandson turns 16 or whatever, however you want to say it. So you don't have to write a novel, right? You don't have to write a whole paragraph, one sentence. And if you're stuck on how to do it, you're just going to turn the question around. You know, how much must Ms. Kim invest today at 6% compound monthly? Ms. Kim must invest today this amount of money at 6% compounded monthly if you wanted to put all that stuff in. But just answer the question. Okay, that answers the question, what I just wrote. Okay. I guess we should probably check to see if how the book did it. Hopefully we got the same answer. Yeah, okay. I would, right to the penny, which it should be the case, right, when we're working like this. Okay, well that was a case where we had an amount in mind and we needed to know the principal. That's probably a fairly common one. And now that you know how to do that, you could do the same thing, right? You go to your bank and you could say, all right, what are your GIC? What are your rates for your GICs? You can even go online and check, right? What are your rates for your term deposits? Work, you know, get those rates, and then you say, all right, when, you know, my son turns 19 and he wants to go to university, we're going to give him $5,000. What do I have to put in now? Okay. But that's one way to do it, and that only works if you have a lump sum of money, right? There are other ways to do it, and we're actually going to look at that in the next the next lesson, where instead of having a lump sum, you basically put a little bit aside every month, and then you have a certain amount at the end. Okay, and it's more than just savings because interest also accumulates. So there is another way to do it. You don't just have to, you know, like Mrs. Kim had almost $7,000. You know, most of us don't have that. So, especially when we're young. So there's another way to do it with an annuity or you know, a savings type program where you're putting money aside every month or every week. All right, now looking at this, there's another thing that we have to be able to do with this compound interest formula. Okay, we found the principal, so that was just manipulating the compound interest formula. Now, how about finding the interest rate? Okay, in other words, solving this thing for I. Okay, now the book it says that there's a couple of ways to figure out I. There are some mathematical methods that will let you figure out I pretty directly, but, and I sorry to disappoint you, you're probably going to have to wait till you get to college or maybe grade 12 before we look at those methods. So we're just going to use what's called guess and check, and it's actually not so bad. Okay. So it says here a principal of $625. Okay, so that's our P. Amounts, well, that's our A, to $1,028.37 in 4 years. The interest was compounded monthly. What is the annual interest rate? So they want the I. They don't know what the I is. Okay. You could even say that. You could say, all right, well, what interest rate would I need to work this out, right? That's a common kind of thing. Okay. So let's try this. I'm just going to make a new page, and as usual, I'm just going to sort of wander off and solve it. This is example 2. So I'm going to solve it my way, and hopefully maybe it'll be a little different than, all right, I'm not sure what happened there. It might be a little different than the way the text did it. Okay. So let me switch here. So we have the principal. Actually, we have the amount. We know what the amount is supposed to be. The amount is supposed to be $1,028.37. The principal is going to be $625. These are all dollar amounts. Should probably put that in there. And so P equals I, and then we need N. Now we know that it's 4 years and it's compounded monthly. Okay, so question mark over, so that's going to be question mark over 12. And just going back down to the bottom, it's going to be, what is that, 48? Yeah, 48. All right. So this is what we don't know. This is our I value. Okay. Okay. And when we're figuring out the I, there's two things we can do. We can either have a rate in mind and just keep plugging the rate in and working out a new I, or we can just work out the I with the idea that eventually we're going to have to divide it by 12. Okay. So we can do it either way. For me, it's probably just as easy to just work out the I. Okay. Now remember that our formula here is A equals P times 1 plus I to the power N. So let's fill in everything we know here. Okay. Well, we know it's actually, let's try this. We have P. All right. Oops. I'm going to back up a little bit. All right. Our P is going to be 625, and 1 plus I. I to the power 48. Okay. So what could our I be? Remember that we want this, we don't know if this is equal. That's supposed to be a question mark on top of the equal sign. It's got to be 1,028.37. Ooh, that got really kind of ugly. Let me fix that here. Wow. Okay, get a bigger eraser. Okay. So 1,028.37, and we're not sure, okay, if they're equal. Okay, we need to pick an I value that's going to make those equal. Okay, so let's pick an I value. We have no idea, right? So let's say that I was 5%, right? Which is 0.05. Okay, so then our I value then would be 0.05 over 12. Okay, and let's just try that. Okay, so I'm going to plug in 0.05 over 12. Okay, and then we're going to see what this works out to be. This is called the guess and check method, and you'll see once we do it a few times how this works out. So it's 0.05 divided by 12 plus 1 to the power 48 times 625. Okay, and the amount we get is 763.06. So it's 763.06, which is way too low, isn't it? It's way too low by quite a bit. Okay, so that I value didn't work. That was I equals 0.05 over 12. So that was no good. But it gives us an idea of where we want to start. Okay. So and where because we know the interest rate has to be higher, right? It has to be higher than 5%. Okay. So what should we pick next? Well, that's a pretty low number. Let's pick something a little higher, like 8%. Okay. And we'll try that again. So what do we get when we work this out? We get 625, 1 plus 0.08 over 12 to the 48. Okay. All right, let's try it. So it's 0.08 divided by 12 plus 1 to the 48 times 625. Okay, well, that's 859.79. Ooh, that's I was really really low there. Okay, so that's not going to work. But again, I was I thought we would be above it. So let's try something really extreme like 12%. That's a really high interest rate. Okay, so now we're going to go 625, 1 plus 0 point. Now watch it. That's 1, 2, because we're greater than 10 on the interest rate. Okay, and what I'm hoping is that we're going to be above. If we're off, I'm hoping that we'll be above, and then we'll start bringing it down. Um, yeah, I was a little surprised that that last one didn't do it. Plus 1. Okay, to the 48 times 625. Okay, well, we're getting closer. That it turned out to be 1,007.64. How am I doing compared to what we need? We need 1,000. Ooh, we're very close. Look at that. Okay, well, what if we tried 13%? Now, the question you have to ask yourself is how accurate do you want to be here? You know, how many decimal places? I think we should get pretty close. So let's try 13%. 625 times 1 plus 0.13 over 12 to the 48. Okay. So 0.13 divided by 12 plus 1 to the 48. This is really test your knowledge of this, how to do this, give you lots of practice solving this. Okay, and I got 1048.33. Okay, and what was I looking for? 1028. Okay, so we're a little high, so it's somewhere between 12 and 13%. So depending on how accurately we want to do this, we could say 13 because it's really close, or we could say 12. But let's try. How we're closer with the 12, aren't we? Let's try 12.5%. Okay, here's 12 point. Oops, sorry, didn't mean to do that. Okay, so I equals 0.125. So that's no 12.25%. 12.25% is what I want to say. That's going to be 0.1225 divided by 12. I think that could be it. All right, let's try that. 25, 1 plus 0.1225 over 12 to the power 48. Okay, and if not, I think that would be pretty close. 0.1225 divided by 12 plus 1 to the power 48 times 625. Okay, is 1017.67. Huh, well, that's interesting. You know what? I think that, oh, we want 1028. Oh, we're still a little low. Okay. Well, maybe we could call it 12.5%. 125 over 12. Okay. 1 plus 0.125. And you could just take this as to as many decimal places as you need. The guess and check method. One of the reasons I took one extra step, I think, is actually maybe even two, because my guesses were too low. My second guess was too low. The idea is that your first guess establishes which direction you want to go, and then your second guess will be too high or too low, depending, and then that'll give you an idea of whether you go from your second guess down or from your first guess up. And in my case, I think I wasted a couple of guesses because they were too low. Okay, but usually you zero in a lot faster than I did. All right. 0.125 divided by 12 plus 1 to the power 48 times 625. Okay, and there you go. So 1027. Oops, 1027. 77. And you know what? I'm gonna call it that. I'm gonna call it 12.5%. It's, it might be 12.6 or something. Okay. So that's how you do it. And you can see that they actually, and now I'm looking at the text here on page 17, and they actually got a very specific interest rate. The way you could do that, by the way, is once you, yeah, there's different ways to get a little closer, but anyway, that's as close as I need, 12.5%. Okay. So that's called the guess and check method. Now, if you could also set up a spreadsheet in Excel, if you knew how to use Excel, you could go in and you could set one up that would calculate it for different values of I, right? And then, so that's sort of guess and check, but then you right, would have a pretty good idea of what I was. Okay. Now it says here on page 17, it says, helpful hint, when the guess and check method, when using the guess and check method, let me just back up a little bit here and we'll show you what we're talking about here. Oh, all right, well, let's go forward a little bit. There we go. So yeah, so there you see they did it, it was too small. Oh, okay, well they did a couple of ways to guess this too. To me, the idea is to bracket it, right? Like if the actual value is here, right, you try your first guess and it's too low, so then your second guess should be too high, and then you decide whether you're closer, whether you're going to work up or work down. Okay. In my case, a couple of guesses wasted, but it looks like they did the same thing, so hey, not so bad. Now, it says here, helpful hint, it says when using the guess and check method, it is important to be patient and try to get as close to the expected target as possible, right? And it's true. I stopped at 12.5%, mainly because interest rates are usually just given in one decimal. They kept going, so in the book, whoever was doing that question is much more patient than I was. Okay. Now, that's one of the things that we're going to try and figure out then is what the interest rate. It's a useful skill. It's maybe not used as much as the other one as finding the principal forgiven amount, or even this one, finding the number of compounding periods. The next one that we're going to look at. As a matter of fact, this one, the number of compounding periods, you'll actually, if you ever go in and you're at a new car dealer and you want to buy a truck or a new car, usually a truck, if you're sitting there, they might actually give you a computer to use where you plug in a certain monthly payment and it'll figure out how many months your loan should be, or you'll plug in how many months, which is N basically is what you're working out, and it'll tell you what your payment will be, right? So they will actually give you that computer and let you play with those numbers, right? Now that seems very helpful, but let me tell you that they're actually collecting information from you when they do that. What that tells them is what you're sensitive to. Some people are sensitive to the price, right? They want to pay 50,000 for their truck, not 60,000, right? Some people are sensitive to the monthly payment, right? They want to pay $400 a month, not $500 a month, right? So the car dealer or the truck dealer, when they see whether you're looking at the monthly payment or whether you're looking at the number of compounding periods, right? They'll start talking about in terms of if it's price, they'll start talking about in terms of price, and if it's monthly payments, they'll start talking about monthly payments, right? So you're giving them a little bit of information when they let you play with that piece of software. And the best defense against that is to go through these calculations yourself. And we'll have plenty of opportunity in the course to see exactly how you would do that. Okay, let's see. I, I went ahead a little too far here. So we're at the bottom of page 17, and I'm actually going to change to green here. It says finding the number of compounding periods. So the next one that sometimes we want to know is n. And again, we're going to use the guess and check method. Okay. How long does it take money to triple? Whoa, triple. That means times 3. Means go up times 3 at 5% compounded semi-annually. Semi-annually? That's two compounding periods per year. Okay. Now, you don't have to make the calculations complicated. They said that for $1, right? Because it's triple, it doesn't matter. It could be any amount, but why not just pick the easiest one to use? So we want $1 times 3 gives us $3. That's triple. Okay. So that means that our A is going to be $3 when our P is $1, right? We start with $1 and then it triples, it times 3. Okay, the amount, and it could be any amount, right? We're looking for a value of n that makes that happen. So if you have $100, you'd have $300. If you had $1,000, you'd have $3,000, and if you had $1,000,000, well, you'd probably hire someone to calculate it for you. So n, we're going to find out n here. All right. So we're going to plug in everything we know. We want the 3 as our amount. We want the 1 as our principal. And we know, now how do we work out our I? Well, the I was that it was semi-annual, which is 2 compounding periods per year. Okay. And the interest rate is 5%, 0.05. Watch that leading zero. We know it has a 0 to the right of the decimal because the interest rate is less than 10. We'll always have that 0 there. So that's our I. Okay, now they did, I don't like the way they did it here. They put 0.25, which is just I, 0.025. But I guess it's all right. So all they're doing then is, and then they did one more calculation, which is they did the stuff inside the brackets, 1 plus 0.025. So now it's a pretty straightforward thing. We have 3 on one side, we have 1.025 n, and it's just a matter of trying to find the value of n, right? Now remember that n is 2 times the number of years. We don't know what the number of years is, right? Okay, so we got to be careful there because our n value, whatever we end up with, is going to be, then we're going to have to convert it back to years. Okay, so this is where understanding the question, step 1 of the 4-step problem solving model, really is critical. Right? Understand what we're trying to get, because if we didn't understand that n was actually the number of compounding periods, not the number of years, we could easily give an answer that says, it's so many years, when in fact that it's the number of compounding periods. Okay. All right, so they're going to do a bunch of guesses. I'll spare you from from my method of guessing. They tried n was 10. Now, how many years is that? Right? It's 5 years, right? 2 compounding periods per year. Okay. Now they ended up with 1.28. Remember, we want 3. Okay. So then they tried 50, which is 25 years, and it was too high. And notice, so now they bracketed it, right? So the answer's here somewhere. Okay. They took a shot at with 10, and it was too low. Then they took another shot with 50, and it was too high. But what we notice is that the difference between 50 and the actual answer is smaller. So in other words, this asterisk was actually closer to here. So then they started going down from 50, right? If it had been closer to 10, the answer had been closer when they used 10 than 50, then they would have started back at just above 10. Okay, so if you ever play battleships, the peg game where you put your battleships out and then you call out a grid coordinate, and if you hit the battleship, then you have to start looking around to see which direction the person's ship is. And that's what we're doing here. We're kind of calling out a number. We're too low, we're too high, and then we're just kind of zeroing in on the number we're looking for. Boom. We only have to land on it. We don't have to land on it twice. So they do a bunch of guesses, and here we go. Their fifth guess, so they said 45. I wouldn't have even picked 45. 44 and 45, I see. So just under, just over, pretty close, right? So what did they say here? They said it's 0.04 is just under 3 for 44, and 0.04 is just over 3. Okay. Because the number is the same, use common sense. In this case, semi-annual means 2, so that use the even number, 44, to get a round number. So they came out with 22 years. So what they said was, you know, we couldn't find it exactly, so we just said, all right, let's just round it to an even number so that we can use divided by 2 and get years. Okay. Now notice what they answered the question. At 5% compounded semi-annually, money triples in 22 years. Okay, which is true. It's not 21, it's not 23, and it's not even 22.5 years, it's 22. Okay, now the fact is that it's a little over, what, is it a little over, a little under? Yeah, so let's see, what did they use? Yeah, it was a little under, just a little over 22 years. But for our purposes, that's close enough. Okay. So I think that's pretty much all of the content. And now we have the support questions, which are going to help you solve the key questions. And I think the key questions in this, it's a relatively few number of key questions. And you'll get that in the course. Sometimes they don't give you that many key questions. Okay. So let's take a look at these support questions. Says Tricia has $1,500 in her bank account, so maybe that's going to be her principal. Who knows, right? She wants to buy a CD player. A CD player? What is that anyway? They used to have those a long time ago. She wants to buy an iPad. Right. All right, she wants to buy an iPad and invest the remainder at 6.5% compounded quarterly for 4 years. That's 4 times a year. At the end of the 4 years, Tricia wants $1,500 in her bank account. Approximately how much can Tricia spend on the iPad? You notice I changed it, right? Because we don't have CD players anymore. Okay. So how are we going to solve that one? Okay. So again, the 4-step problem solving model, the first step requires that we understand the question. Okay. So let's try and understand the question. I'm going to make a new page here. You can look at this question on page 18. This is page 18 of Unit 2 and support question 1. I'm just going to take a look at my, okay. All right, I see someone's online here. Unfortunately, I don't know who's watching us on Smart Bridget. If you could send me a chat message and tell me who that is, I'd really appreciate it. Because it's not given your name, it's given somebody else's name who set up the software. Okay, so support question 1 then. So we A, P, I, and N. Those are our variables that we might have. So this is a little complicated, isn't it? She has $1,500 in her bank account. She wants to buy the CD player and invest the remainder at 6.25%. Okay, you know what we need to do? What we need to do is we need to know what the principal is, isn't right? Like I think, like we want the amount to be $1,500 at the end. We don't know how much principal. In other words, she has her $1,500. She can spend some of it. We don't know how much of that's going to be, but we can work out what it needs to be, the principal. And then the interest rate, I think we're going to be all right. 6.5%, so that's 0.065. That's 6.5 compounded quarterly. So that's 4 per year. Okay, and N is the 4 compounding periods per year times 4 years, so our N is 16. So we have everything we need except the P. Now understand what the P is. The P is how much he has to invest now to end up with $1,500. Now where did she get that P? That P is what's left over after she spends her money on her iPad. And so once we know what that P is, then we can figure out how much we take away from her cash. So the $1,500 she has in her bank now, it's a bit of well, I don't know if it's a red herring, but it's not the A, right? She wants to get back to that amount, but she has $1,500 now, but she's going to spend some of it, and then whatever's left over goes as the P in her investment. Okay. All right, so I've got about 4 minutes. I don't know if we're going to get this one done today, but that's fine. We'll get it started anyway. So 1,500 equals P times 1 plus 0.065 divided by 4 to the power 16. Look at that. We're going to be able to work this out. 1 plus 0.065 over 4 to the power 16 equals P. Okay, so I'm going to crank that through my calculator and see what we get. 0.065 divided by 4 plus 1 to the power 16. And then I actually divide that by 1,500, and then you take the reciprocal 1 over x, and I end up with a P of 1158. Okay, sorry, it's going to be 1159 because it rounds off, equals P. So that's how much she can put in, right? So how much can she spend on her iPad? Okay, iPad. Okay, if she has 1,500, she needs 1,159. That means that she can spend 1,500 minus 1,159. She can spend $341 on her iPad. Okay, that's how that works out. Now I'd go and check at the back there, Tricia. Okay, and you know, whether it's an iPad or whether it's like you know, a snowboard or an ATV or something that you want to get, that's one of the ways that we do things in life. You know, we have a certain amount of money. We want to spend some of it. We want to save some of it. We want to invest some of it, and you can do these calculations. Once you know how, you just sit down and you do them. Okay. So I guess that's going to be it for today. We just wrap things up. And remember, there's no class tomorrow. It's Friday, so we'll come back on Monday. We'll take a look at the last little bit of this lesson. We'll probably go a little slower next week just because that lesson 9, there's a lot of stuff in it. So we'll probably take a couple classes to do that. And that's it. So let's wrap it up then. And thanks for joining me today, and we'll see you on Monday.